Okay, so for the first example, again, when it gets really confusing because there's cosines and sines now, you have to remind yourself that it's kind of like you're solving this equation here. That's the way you're going to think of it. So let's just see what would happen if we were to go and solve this. I'd be looking for, looks like x plus 1, x minus 2. So really, what that means in this case is I have cos x minus 1 and cos x, plus 1 minus 2? Yeah, plus 1 minus 2. So this is the equation I'm actually trying to solve. Okay, but they're very similar whether you use x's or cosines. And that gives me two pieces. One where cos x equals to negative 1, and another where cos x must equal to 2. So the nice part about this is we can immediately go like that and say there's no solution to this example. But for cos x to be equal to negative 1, that's going to be on the unit circle. So at negative 1, the x-coordinate is here. That is the angle x equals to pi. Okay, so for this equation, there's actually only one solution. It happens at x equals to pi. Okay, so I'd like you to try that. See if you can do x squared plus 2 sine x minus 3 equals 0. And see if you can factor and solve. Okay, so again, if it's getting confusing, this is where I would say you want to start to think. This is the kind of parallel equation you'd be solving. So to factor this, it would be x, let's see here, plus 3 and x minus 1. That means the one I'm actually trying to solve is the sine x plus 3 and sine x minus 1 equals to 0. I might as well get rid of this, move it out of the way. Nothing? Sue's not working, I'll just erase it. Okay, so this is what I'm trying to solve. The first part here, that would need sine x to be equal to negative 3. That can be rejected, it cannot happen. Sine has to be between negative 1 and 1. The second piece, however, I need to find out where sine x equals to 1. That can happen. We can go on to the unit circle to find it. It is the y-coordinate that I'm looking for. The y-coordinate equals 1 when I'm at the top. So that's going to be the angle 90 degrees or pi over 2. Okay, so again, there's only one answer. That should be pi over 2. Okay, so do you remember how to factor this kind of equation? Any ideas? Yeah? Hari thinks she knows. What did you do, Hari? Mystery method if you like? Sure. So the way I would start these is I would multiply the first term and the last term. So again, I'll show you, this is the parallel example that you're thinking about. You're actually factoring this. So that'll be x squared plus 5x minus 6. And this will be x minus 6, sorry, x plus 6, x minus 1. Now, this is something I catch even you guys doing this. Be careful. Remember, at this point, because you multiplied by 2, you still have to divide by 2. So you end up with x plus 3 and x minus a half. And I get x plus 3 2x minus 1. So this is the factored form, which for my example, it actually means I factored this to be cos theta plus 3 and 2 cos theta minus 1. Okay. So this is actually the equation I should have been solving. This one here would tell me cos theta has to be negative 3. That cannot happen, so I can reject it. Don't need to look for an answer there. This one would be where cos theta equals to 1/2. And I need a special triangle to help me out. The triangle I'm looking for has the lengths 1 and 2. So this is the triangle I'm looking for. So cosine is the adjacent over hypotenuse. It's going to be 60 degrees. So my reference, 60 degrees or pi over 3. That only tells me the reference angle. Now that I know the reference, I have to think about where is it going to be in the quadrants. Cosine is positive here. This is a positive number. So it's going to be these two angles that are positive, and the reference will tell me what they are. This one is pi over 3, because I have a reference here of pi over 3. If this is my reference of pi over 3, then going all the way around, except for pi over 3, the whole way is 2 pi. So I'm pi over 3 short of the whole way, which means I'm going to be at 5 pi over 3. So my answer is going to be, sorry, this is theta. My answer is going to be theta equals pi over 3 and 5 pi over 3. Okay. So I'll have you try one where you do that mystery method of factoring. Not this one. Let's try this one here. Okay, so to factor this, 2x squared, oops, somebody's bumped the Wiimote, just a sec. Okay, so 2x squared minus 3x plus 1, and to factor this, don't forget, because I'm multiplied by 2, I'm going to have to divide here. So I have x minus 1 and 2x minus 1. So for the equation that I was working on, what I really have here is I really have sine x minus 1 and 2 sine x minus 1. Okay, so the two equations that I'm looking at, the first one is where sine x equals 1, and sine is the y-coordinate. That's the position right there. So that happens at 90 degrees or pi over 2. Okay. There's no, I'm sorry, apparently my brain is not quite awake yet, even though it's after lunch. The y-coordinate does not equal 0 there. The y-coordinate equals 0 there. My apologies. So that means here it's at 0. And here it's at pi. So those are two of my possible answers. I just did it wrong. I just did it right, and then I did it wrong, right? Okay. I'm not sure why I was looking for 0. I must have been this was messing me up. It was right before. Up there is where it equals to 1. 1, 1, 1, 1. There, okay. So at 1 is pi over 2. And the other equation, that's when sine x would have to equal to 1/2. So that would be 1, 2, root 3, 30, and 60. So that's going to have a reference angle of 30 degrees or pi over 6. So if it's going to equal to 1/2, that's going to be positive. So it's going to happen in quadrants 1 or 2, where the reference angle for both is pi over 6. So that means I end up at 5 pi over 6 or pi over 6. So here are my 4 answers. 3 answers right there for that equation. Can I just see by a show of hands how many people were able to get that? Excellent.